Bismillahirrahmanirrahim. Assalamu alaikum students. Today I'm going to start a course for 12th class students. So I named this course as Problems in Physics for class 12. So in this course, I will discuss problems related to the syllabus of physics, the syllabus which is taught in the higher secondary schools of our whole country, India, and in our state in particular, that is class 12th syllabus. So I may be discussing one problem in a lecture or two problems in a lecture depending on the difficulty level of the problem. So it will be helpful for all those students who are afraid for solving a problem, who don't attempt to solve a problem in physics. It will be good for this course. I hope you will enjoy this course, and in addition it will be helpful for all college going students. Why so? Because most of the college going students in our state and in our country in general don't do a course in problems at their higher secondary level. So it will be helpful for college students as well. So today is the first lecture of the course. I'm starting with a problem. So let me write the problem straight away. The problem goes like this. So I name it problem first. I will not number these problems, I will write problem. The problem says figure 1 shows three charged particles. Three charged particles held in place by forces not shown. Let me change the color. What electrostatic force, what electrostatic force owing to the other two charges acts on Q1. Then the question says, take Q1 equals minus 1.2 microcoulomb, Q2 equaled plus 3.7 microcoulomb, Q3 equaled minus 2.3 microcoulomb. R12 is equal to 15 centimeter. R13 is equal to 10 centimeter, and theta is equal to 32 degrees. I will check this question. Figure 1 shows 3 charged particles held in place by forces not shown. What electrostatic force owing to the other 2 charges acts on Q1? Take Q1 equal to minus 1.2 microcoulomb, Q2 equal to plus 3.7 microcoulomb, Q3 equal to minus 2.3 microcoulomb, R12 equal to 15 centimeter, R13 equal to 10 centimeter, and theta equal to 32 degrees. So let me draw the figure. So the figure is like this. This is my XY plane. Let me name it first figure 1. Let me change the color. I have Q1 charge placed at the origin. This is Q1. Then I have another charge Q3 placed here. This is Q3. And I have another charge here. It is positive charge. This is Q2. And we use another color. This is the line drawn this way to make it clear. This angle is here theta, this angle. So this distance is R12, and this distance is R13, right? So we have 3 charges, 2 negative charges, Q1 and Q3 are negative charges. Q1 is at the origin, Q3 is placed at this location shown in the figure. Q2 is positively charged particle located on the x-axis as shown, and distance between Q1 and Q2 is R12, which is given. Distance between Q1 and Q3 is R13, which is given. This is a figure. As you can see, we are supposed to find the net force on Q1. And we know Q1 will experience force due to Q2 as well as force due to Q3, right? Q3 will repel Q1 as they are like charges, and Q2 will attract. So let us show those 2 vectors in the figure. I will use another color. Let me use this color. So this I am showing this is my F12. What is F12? It is force on Q1 due to Q2. Force on Q1 due to Q2. Q2 is going to attract Q1 towards itself, so this force will be oriented this way. Likewise, Q3 will repel Q1, so that vector will be this way. So this force is, now I name it, let me make it little bold. This vector is F13. What is F13? It is force on Q1 due to Q3. Due to Q3. So F13 is our force on Q1 due to Q3. F12 is force on Q1 due to Q2. Q2 is attracting Q1. Q3 is repelling Q1, right? And we are supposed to find net force on Q1. So what we will do, we have to use the superposition principle. You know, from superposition principle, if F1 is net force on Q1, then from superposition principle, F1 will be the vector sum of F12 and F13. So we have to vectorially add F12 and F13 in order to get the net force F1. So how we are going to do that? We have to see the figure and use the given information. You can see if this is angle theta, this is also then angle theta, right? They are vertically opposite angles, so they are equal. So what we are going to do, we are going to first find the magnitude of F12 and F13, right? So magnitude of F12. F12 can use Coulomb's law in scalar form, 1 by 4 pi epsilon naught, because we are assuming these charges are placed in vacuum, times Q1, Q2 over distance between 1 and 2, which is R12, and we have to square that. It is 1 by 4 pi epsilon naught Q1, Q2 by R12 square. Let us substitute the values. So we substitute the values. Let's write like this. Value of 1 by 4 pi epsilon naught is, you write it exactly, 8.99 into 10 raised power 9 Newton meter square per coulomb square. Newton meter square per coulomb square is the SI unit of this constant. Then we have to put the charges. Q1 is 1.2 microcoulomb. That is 1.2 into 10 raised power minus 6 coulomb. And you have to multiply another thing. I write it upstairs. Then multiply by Q2, which is 3.7 microcoulomb. 3.7 into 10 raised power minus 6 coulomb. As you can see, Q1 is 1.2 microcoulomb. 1 microcoulomb, 1.2 microcoulomb, we are taking magnitude. 2 is 3.7 microcoulomb. So we are substituting for first I'm finding QF12. Q2 is 3.7 microcoulomb. Okay, Q2 is 3.7, Q1 is 1.2. 1.2 microcoulomb, 3.7 microcoulomb. So I have replaced the micro by 10 raised power minus 6. And I have distance between R1 and R2, which is, I think, 15 centimeter. I will convert it into meters. So it will be 0.15 meter square. So when you put the numbers, you will get 1.77 Newton. This is the magnitude of F12. Let me encircle it, use green color. We have calculated the magnitude of F12, 1.77 Newton, but you need to check it at home. Check it. Now, we will find the magnitude of F13. F13 is, again, the value of the constant, which is 8.99 into 10 raised power 9 Newton meter square per coulomb square. Then I have Q1, which is 1.2 into 10 raised power minus 6 coulomb, as it is 1.2 microcoulomb. Then I have Q3, which is 2.3 microcoulomb, that is 2.3 into 10 raised power minus 6 coulomb. Then I have distance between 1 and 3, which is 10 centimeter. So it is 0.10 meter square. You can check it. 1 is 1.2 microcoulomb, Q1. Q3 is 2.3 microcoulomb. As you can see, Q1 is 1.2 microcoulomb, Q3 is 2.3 microcoulomb, and 3 distance between 1 and 3 is 10 centimeter, which is 0.10 meter. You scan that. When you put the numbers and do the calculations, it will turn out to be 2.48 newtons. So we have calculated the magnitude of F13, 2.48 Newton. I again say you need to check it at home. You multiply these numbers and divide by distance square and check the number. Now, you know this property of vectors. F1 is the vector sum of F12 and F13. Therefore, x component of F1x, if represents the x component of F1, it will be sum of the x components of F12 and F13. That means it will be F12x plus F13x. Similarly, F1y, y component of the net force, will be F12y plus F13y. Same goes for z component. But here the vectors are in the plane and there will be no z component. So I will find first x component of F1 by adding the x component of F12 and F13. Then I will find the y component of my resultant force by adding the y component of F12 with the y component of F13. So let us proceed. I will use another color now. F1 now, F1x is F12x plus F13x. Now F12x is just F12 and F13x is F13 sine theta. I will explain it to you from the figure. I am saying F12x is just F12 and F13x is F13 sine theta. F12 being the magnitude of F12 and F13 being the magnitude of F13 vector. Let us go to the figure. This is the figure. Since F12 vector is parallel to x-axis, so it has no y component or z component. It is having simply x component. Its full magnitude is its x component. But F13 we have to resolve. When you resolve F13, it is making angle theta with y-axis. So F13y, its y component will be F13 cos theta. And its x component will be F13 sine theta. But remember, the y component of F13 is pointing downward, so it will be negative in the sum, and its x component is pointing along positive x-axis, that will be positive. So you know it. Still, I am trying to remind you. So F12 we have calculated is 1.77 Newton plus, then we have calculated F13 which is 2.48 Newton, but you have to multiply with the sine of theta. Angle is given 32 degrees, so it is sine of 32 degrees, right? 1.77 Newton plus 2.48 Newton times the sine of 32 degrees. When you do the calculation, you will get it 3.08 Newton. So we have calculated the x component of the resultant force as 3.08 newtons, right? Now let us move to the y component. Next page. Now my F1y is F12y plus F13y. Now, what is the y component of F12? That is 0. And it is minus F13 cos theta. As I have told you, F12 vector is parallel to x-axis. Its y component is 0. But F13 has y component, which is F13 cos theta. But in the sum, it is to be taken as negative, as it is pointing along negative y direction. So let us move. It is F12y plus F13y. F12y is 0. F13 we have calculated. So it is minus F13 is 2.48 Newton cos of 32 degree minus 2.48 Newton times cos of 32 degrees. So when you do the calculation, it is minus 2.1 Newton. 2.10 Newton. So it is F1y. So we have calculated the x and y component of our net force. As you can see, X component is this of net force 3.08 Newton, and Y component of the net force is minus 2.10 Newton. From these components, we can find the magnitude. How we can find the magnitude? How we can find the magnitude? You know, magnitude of F1 will be square root of F1 x square plus F1 y square. This is your simple vector rule. If you know the components, you can find the magnitude. The magnitude of F1 is square root of F1 square plus square root of F1 y square. When you do that, you can check it. The magnitude of F1 turns out to be 3.73 Newton. Magnitude of F1 is 3.73 Newton. Let me encircle it. We need to check it. So check it. Then you have to find the direction. Direction you can find tan phi, angle made by the vector, will be, if phi is the angle made by F1 with the positive x-axis, measured in counterclockwise sense, as you know, it will be y component by x component, F1y by F1x. When you do the calculation, phi will be minus 34 degrees. So the magnitude of the resultant force F1 is 3.73 Newton, and the angle made by this vector with the positive x-axis is minus 34 degrees Celsius. Let me encircle it. So we have solved our problem. That means minus 34 degrees means this F1 vector will be, if this is F1 resultant, I'm showing it approximately. This angle, let me use another color. This angle will be 34 degrees because it's minus. You have to take this angle in clockwise sense. Clockwise sense with x-axis, it will be 34 degrees. Because we have found it to be minus 34 degrees. So it will be 34 degrees in clockwise sense this way. So we have obtained our result. We have found the net force on the charge Q1. Its magnitude is, what is the magnitude? Magnitude of the resultant force is 3.73 newtons, and angle made with the positive x-axis is minus 34 degrees. So this is all for today, but you need to check all the calculations yourself. Don't forget to like and subscribe my channel. You can also comment in the comment box. Thank you. God bless you. Assalamu alaikum.